The fundamental theorem of algebra is one more concept that we want to talk about before we finish with polynomial functions. And this is one that you already know, even though you didn't know it was called the fundamental theorem of algebra. In other words, we've been talking all along about this theorem. You just didn't know it. The theorem actually is very easy. It says that the total number of roots of any polynomial is equal to the degree of the polynomial. In other words, if you have a degree of 5, then you have 5 roots. And you already knew that. But the roots can be real or imaginary or a combination of both. And you already knew that too. A couple of things we want to make sure that we remember. Polynomials do not have negative exponents. Polynomials do not have fractional exponents. Polynomials do not have irrational exponents. And polynomials do not have variable exponents. Now you knew all of that too, but I want to make sure that you remember that, because when we talk about the fundamental theorem of algebra, we have to remember we are actually talking about polynomials. All right, let's put this into practice. I have a polynomial. I want to know how many roots this polynomial has. And then without using a calculator, I want to know how to find them and what they are. So what's my polynomial? My polynomial p of x is equal to x to the 5 plus 3x squared minus 4x. So how many roots does it have? Well, what's the degree of this polynomial? Is it in standard form? It is. That means that my degree is 5. So I have 5 roots. Are they all real roots? Don't know. Are they all rational roots? I don't know that either, but I do know there are 5 roots. So how can I find these roots without using my calculator? Well, I can factor it. And as I'm looking at my polynomial, I notice that all 3 terms have an x in common. So I can factor my polynomial p of x to be x times x to the 4 plus 3x squared minus 4. Okay, it's factored, but it's not factored down to its prime factors, so I'm going to have to factor it again. Of course, I'm not leaving out the x. That was one of my factors. But now I want to look at x to the 4 plus 3x squared minus 4. Well, since x to the 4 has a coefficient of 1, I'm wondering, can I factor this fairly easily? Well, let's see. What are factors of negative 4? That when I add them together, I get a positive 3. What about a positive 4 and a negative 1? Would that work? If it does, then that means that I have x squared plus 4 and x squared minus 1. Let's check it real quick. X squared times x squared is x to the 4. X squared times negative 1 is negative x squared. And 4 times x squared is 4x squared. They are like terms, so 4x squared plus a negative 1x squared, that is 3x squared. And 4 times negative 1 is negative 4. Now it's factored, but it's still not factored completely because I have x squared plus 4 and I have x squared minus 1. Can I factor them again? Well, let's take a look. This is a sum of 2 squares. Well, we know that can be factored into imaginary complex factors. In other words, this becomes x minus 2i and x plus 2i. And x squared minus 1, that's a difference of 2 squares. I know how to factor that also. That's x minus 1 and x plus 1. Hard to fit that last one in there. Let's write it down below. Now I have all my prime factors. And how many factors do I have? I have 5 factors. If I have 5 factors, that means I found all of my factors, and now I can find my roots by setting each factor equal to 0. So x equals 0, and x minus 2i equals 0, and x plus 2i equals 0, and x minus 1 equals 0, and x plus 1 equals 0, That means my factors are 0, 2i, negative 2i, 1, and negative 1. I have 5 zeros. I found all 5 solutions because I have 5 roots. We'll try some more in class, but go back and rewatch this and make sure you really have this down.